Hello and welcome again, everyone. Today I'm going to simplify for you the homologous series. Now you would be looking at the homologous series if you're doing organic chemistry. All right. Now, first of all, if you're looking at the homologous series, you must know what it is. The homologous series really is a system of classification. And you may ask yourself, but what are we classifying? Well, you're classifying the different types of organic compounds, okay? Now, because of the nature of carbon, there is a vast number of different organic compounds. And the homologous series is where we classify them and put them in these different groups called homologous series. Now, there are certain characteristics or features which are common to all the different classes of organic compounds. And we're going to look at those first before I simplify the homologous series for you. Now, the first thing is that each class of compound, there is a general method of preparation. All the compounds in that group can be prepared in a certain way. So you can prepare all alkenes in a general way, all alcohols in a certain way. Okay, you can prepare all alcohols in a general way as well. So that's the first thing. The second thing is that adjacent carbons differ by CH2. Now, for you to understand this, I'm going to show you an example of what I'm talking about. And we're going to be looking at the first three alkanes. You have methane, you have ethane, and you have propane. The molecular formula of methane is CH4, the molecular formula of ethane is C2H6, and propane is C3H8. Now, if you were to subtract the molecular formula of methane from ethane, you would get CH2. And if you subtract the molecular formula of ethane from propane, you would also get CH2. Now, let's simplify that again for you. Now, let's say you have methane here and you were to cancel the carbon that is common to both methane and ethane. So, carbon cancels carbon. And then you have the hydrogens there. There are 4 hydrogens. So we're going to have to cancel 4 hydrogens here. 1, 2, 3, 4. And what we have left is 2 hydrogens and 1 carbon. And you'll find that if you do the same thing between ethane and propane, you'd get CH2. Okay, now the mass of CH2 is 14 grams. Carbon is 12 grams, and there are 2 hydrogens, each of which have a mass of 1 gram. So the mass of CH2 is therefore 14 grams. So the difference between these two things is also 14 grams. Just a word to the wise there. Okay, so the next thing is that there is a gradual increase in physical properties. Again, I'm going to use the alkenes to demonstrate this. Now, we're going to be looking at the alkenes. There you have that, and the boiling point in degrees Celsius. So you have methane, ethane, and propane. Now, as you can see there, the boiling point of methane is minus 164. The boiling point of ethane is minus 82. And the boiling point of propane is minus 42. So you can see that there is a general increase in the boiling point of the alkenes as the number of carbons increase, because you're moving from carbon number 1 to carbon number 2 to carbon number 3. So there's a general increase in the boiling point. Not only the boiling point, but also the melting point would also increase. And you'll find that as you go along the alkane series, these substances are gases, but eventually you're going to find liquids and then solids. So there is a gradual increase in the physical properties of the species or the molecules in a carbon series. So there you have the 3 generic features of each homologous series. Now, how do I know different classes of organic compounds? How can I simplify it? How can I just look at a compound and say, hey, this is an alkane or this is an alkene? Well, there are 2 things that you should look for. Remember now, Organic chemistry is very vast. So if you get caught up in all the other things, you may just get confused. But there are two things you should look for when you are trying to classify an organic compound based on its class. And those two things are, one, first of all, the general formula. Okay, so the general formula tells you the class of organic compound, and two, the functional group, which is even more important. The functional group is a group of atoms that confer reactivity to the class of organic compounds. In other words, this is the reactive part of the organic compound. This is where reactions will take place. Okay? So, for each class of organic compound, I'm going to show you their general formula and the functional group. All right, so our first class of organic compounds are the alkanes. Now, the general formula of alkanes is CnH2n plus 2. Now, you must always remember, in every single class of organic compounds, N represents the number of carbons. Okay, so N is the number of carbons. And for alkanes, the general formula, CnH2n plus 2. The functional group is carbon single bond carbon. And here is an example of an alkane. So this is a 3-carbon alkane. Now, what you're looking for is the carbon single bond carbon, and you're also looking for that the number of hydrogens is 2 times the number of carbons plus 2. So 2 times the number of carbons plus 2. So this has 3 carbons. So 2 times 3 is 6 plus 2 is 8. So let's check to ensure that we have 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. There you have it. So we know that this is an alkane because it fits the two things, the general formula and the functional group. So our second group of compounds are the alkenes. Their general formula, CnH2n, and the functional group, carbon double bond carbon. So let's look at an example over here. Yes, so in this example, we have a 3-carbon alkene. So remember, you're looking for two things. The functional group. Is there a carbon double bond carbon? Yes, there is. There it is right there. Then the number of hydrogens should be 2 times the number of carbons. So let's just check. There are 3 carbons. So therefore there should be 2 times 3, 6 hydrogens. 1, 2, 3, 4, 5, 6. So there we have it. We know that this is an alkene because it fits those two things. So let us press on to our next class of organic compounds. And that class are the alkynes. All right, wonderful. So the alkynes, their general formula is CnH2n minus 2. And the functional group is carbon triple bond carbon, different from the alkenes. The alkenes were carbon double bond carbon. So let's look at an example of alkynes. There you have it again, right? This is a 3-carbon alkyne. And based on the functional group, we are looking for a carbon triple bond carbon. It's right there. So we know it's an alkyne. But hold on. Let's check. Is the number of hydrogens 2 times the number of carbons minus 2? Okay, in this case, there are 3 carbon atoms, so 2 times 3 is 6, minus 2 is 4. So let's check. 1, 2, 3, 4. There you have it. So it fits the functional group and the general formula of alkynes. So we know this is an alkyne. Okay, so there you have your alkynes. Now, the next class of organic compounds are the alcohols. I know some people get very excited when they hear alcohols because they know that they will be consuming it shortly. All right, so now, here we have the alcohols. All right, now the general formula of alcohols is CnH2n plus 1 OH. And the functional group is COH. So this is what we're looking for here. COH. All right, an example of an alcohol is this 3-carbon compound over here. Now, if you follow the same steps that I've been doing with the alkenes, the alkanes, and the alkynes, you can work out the number of hydrogens based on the general formula. So let's just do this one again. Now, in the general formula, the number of hydrogens should be 2 times the number of carbons plus 1. So there are 3 carbons here. So the number of hydrogens should be 2 times 3 plus 1. And the OH, of course, is separate from that. So let's see now. 1, 2, 3, 4, 5, 6, 7. Wonderful. This is very good then. We're getting the thing. It has the OH and it has the fitting of the general formula. So let us move on to our next class of organic compounds. And this class is our acids. So with our acids, the general formula for very simple straight acids would be CN-1, H2N-1, COOH. Okay, so if you're beginning chemistry, organic chemistry, and you want to write the molecular formula of a simple acid like propanoic acid or butanoic acid, then this formula will help you wonderfully well. Okay, the functional group is COOH, but seeing this, it may be a little bit ambiguous. So what I've done for you is I've written out the connectivity of the atoms. So you have carbon double bond to oxygen, and then you have carbon single bonded to a OH group down here. And this here is our acid functionality. So let's look at an example of an acid. Over here we have a very good example. So this is a 3-carbon acid over here. There you have the functional group, right? COOH. Now you can work out this part of the acid based on the general formula. Remember, this part would be CN-1. Now this is a 3-carbon acid, so therefore it would be N-1, so it's 2. There you have it, 1, 2. H2N-1, so remember now it is 3 carbons, so it is 2 times 3, 6, minus 1, so that's 5. 1, 2, 3, 4, 5, COOH. There you have it. Wonderful. So we know that this is an acid because it fits those two things. You guys are getting it. You're so brilliant. Wonderful. So our next class of compounds is our esters. These are our esters. Now you'd notice here that I've replaced the CnH2 sort of thing with these R groups. That's because esters can become so complex that using that simple CnH2 and becomes a little bit tedious. So therefore we use R groups. So this is the general formula of esters. All right. Now the functional group of esters is COO minus. Now you may ask yourself, where does this minus come from? Now I'll show you in this connectivity diagram down here. The carbon is double bonded to this oxygen, and then it's bonded to this oxygen over here, which is the oxygen with the minus charge on it. And it has a minus charge because of its electronegativity. It pulls the electrons away from this carbon, and therefore it's slightly negative. So we give it a little negative charge because of that. But this is your ester functionality. So let's look at an example of an ester. Wow, this looks amazing. Look at this here. Ester. Remember, esters are sweet smelling compounds. So here you have an ester. And for simplicity purposes, I've used CH3 as the R group. CH3 as the R group. It could be different, but hey, we're all about simplicity here. So you have your two R groups, right, which is often called alkyl groups, right? And then you have your functional group right there in the middle, C double bond O O. So you know that this is an ester once you see this functional group with the two R groups flanking them. Wonderful. Yes, so our next class of compounds are the esters. The ethers, sorry. is our next class of compounds, the ethers. And there you go, I just messed it up. And I was just going to say, don't confuse them, the ethers and the esters. So we have the ethers here, not ester, as I said previously. So your ethers. The general formula, again, because of the complexity of those things, we're using ROR. So you have two alkyl groups flanking an oxygen. And for simplicity purposes, here you have it. Carbon, oxygen, carbon. Right? So this is your functional group of your ether. So let's look at an example of an ether. Oh, there you have your ether. Right? Again, we're using the methyl group because we want to make it very simple. And there you have your COC. So we know that this is an ether because we see the carbon, oxygen, carbon. Wonderful. We're getting this thing. I know you're getting it because of your brilliance. So our next class of organic compounds are the aldehydes. Now the aldehydes belong to a group of compounds called carbonyl compounds. Okay, and ketones is also a part of this group, and we're going to look at that after this one. So your aldehydes, for simple aldehydes now, the general formula CN-1 H2N-1 CHO. Now this can look a little bit confusing, and here you have your functional group CHO, but what is the connectivity? And this is what I'm showing you over here, that you have a carbon double bond to an oxygen, and then the carbon is single bonded to a hydrogen, and your R group would be over on this side. Okay, so this is a carbonyl compound because of this carbon oxygen bond here. The carbon is double bonded to that oxygen, so we call it a carbonyl compound. So let's look at an example of an aldehyde. Here you go. There you have it, right? Your carbon double bond oxygen, right? And you have your hydrogen there. Once you see this, you know it is aldehyde functionality. And of course, you can work out the number of carbons and hydrogens based on the general formula as was given previously. So our next group of organic compounds are the ketones. Anxious. Ketones. Wonderful. These are also carbonyl compounds. And I'm just going to jump quickly. There you have it. Because of this over here, the functional group being C double bond O. That's why they're carbonyl compounds. So the general formula is RCOR. Right, RCOR, and this kind of looks like carbon monoxide, and even down here when I show you the functional group, it still looks like carbon monoxide. It's only when I show the connectivity you realize that it's not carbon monoxide, but a carbonyl carbon. Okay, now I'll show you an example so you can recognize it in a compound. There you have it. This compound here. So there's your functional group, the C double bond O. Now this compound, I must say, is very popular with women because it's used to clean off their nail polish off their fingers, right? And as I said that, as I know you know what I'm talking about. Okay, so there you have it. This is your functional group and your R groups. Again, I'm using the methyl group for simplicity. Okay, methyl group for simplicity. All right, so our next group of compounds now are the amides. The amides. Now, for those people doing biology, you would know that proteins are amides. Now, for amides, the functional group, the general formula is RCONHR. That looks so confusing, sir. I cannot understand that. It's not simple enough for me. Okay, no problem. I will simplify it for you. Here you have the functional group, CONH. Still too complex. Okay, fine. Let's look at the connectivity. The connectivity here is you have a carbonyl carbon, interesting, carbonyl carbon, which means that you have carbon double bonded to an oxygen, and then that carbon is also bonded to a nitrogen, which may be bonded to a hydrogen, maybe. Okay, it could be bonded to other things, but what you are focused on here is the carbonyl carbon bonded to a nitrogen. And here is an example of an amide. Wow. There you have it. See? carbonyl carbon, carbon double bond oxygen, bonded, single bonded to a nitrogen, which is bonded to a hydrogen. And this nitrogen is also bonded to a methyl group, CH3. Okay, making it simple for you. And over here, we also have a CH3 group. You'll notice that I've been using the CH3 group because it is the simplest R substituent that you could get. Okay, so that's why I keep using that one. All right, and I want you to understand the chemistry here behind the functional group. So I don't want to complicate it for you. All right, so there you have your amides. The next class of organic compounds, which I believe is our last, are the amines. Now, you know, if you work in a lab, that amines have very foul odors. I'm telling you. So these things can produce some very foul, pungent odors, which are not pleasant, of course, at all. But anyway, enough of that. The functional group of amines is carbon single bonded to a nitrogen, which may be bonded to hydrogen or to other R groups. And this is your general formula, RCNH2. And of course, for those people doing advanced chemistry, organic chemistry that is, you would know that this is a primary amine. And here is an example of said primary amine. Right? There you have it. You have a carbon single bonded to a nitrogen, and the nitrogen is bonded to two hydrogens. But the carbon is a CH3. Again, I use the CH3 because it is very simple. Okay, so this here is an example of an amine. There you have the functional group. All right, once you see it, you know it. Okay, so there you have it, guys. A simplification of the homologous series. Just remember, you look for the functional group and the general formula to distinguish among your different classes of organic compounds. It is as simple as that. I hope you find this video helpful. If you have any other tips or comments, please leave those in the comment section below. Thank you for watching, and please feel free to like, share, and subscribe to my channel. And I'll see you next time when I try to simplify something for you. All the best.